Good morning, one and all. Today, we are going to solve a very interesting problem in economic load dispatch. So here, take down this problem. The incremental fuel cost in dollars per megawatt hour for 4 units of a plant's are lambda 1 is equal to df1 divided by dpg1 is equal to 0.012 pg1 plus 9.0. Next, lambda 2 is equal to df2 divided by dpg2 is equal to 0.0096 pg2 plus 6.0. Lambda 3 is equal to df3 divided by dpg3 is equal to 0.008 pg3 plus 8.0. Next, lambda 4 is equal to df4 divided by dpg4 is equal to 0.0068 pg4 plus 10.0. If all 4 units operate to meet the total plant load of 800 megawatt, assume that the maximum load on each of 4 units is 200 megawatt, 400 megawatt, 270 megawatt, and 300 megawatt respectively, and that the minimum load on each unit is 50 megawatt, 100 megawatt, 80 megawatt, and 110 megawatt respectively. With these maximum and minimum output limits, find the plant lambda and megawatt output of each unit for economic dispatch. This is the problem that we are going to solve. This is the continuation of our previous problem. If you don't watch the my previous problem, go and watch my previous problem. That also I will give in the description and the comment section, so you can easily watch that previous problem. The same thing we are going to do once again, but here the minimum and maximum operating limits also given, so that also we need to satisfy. So here different lambda also given, different lambda. So whatever the problems that we have seen in our previous classes, that only one lambda will be there. So here 4 lambdas are there. That is lambda 1, lambda 2, lambda 3, and lambda 4. So 4 lambdas are there. So that we going to solve this problem. First, the solution. First, we need to find out the alpha t. So alpha t is equal to 1 divided by alpha 1 plus 1 divided by alpha 2 plus 1 divided by alpha 3 plus 1 divided by alpha 4, the whole inverse. So here easily we can find out the alpha t. That is 1 divided by alpha 1 what? Alpha 1 already given in the problem. This is the alpha 1, this is the beta 1. This is alpha 2, beta 2, alpha 3, beta 3, alpha 4, beta 4. The same thing we need to substitute over here. So just to substitute and simplifying, we are getting the alpha t as 0.002176. Similarly, beta t is equal to alpha t into beta 1 divided by alpha 1 plus beta 2 divided by alpha 2 plus beta 3 divided by alpha 3 plus beta 4 divided by alpha 4. Just we need to substitute all these values for alpha 1 and beta 1. So here alpha t is 0.002176 into beta 1, that is 9 divided by 0.012 plus beta 2 6 divided by alpha 2 is 0.0096 plus beta 3 8 divided by 0.008 plus beta 4 plus 10 divided by 0.0068. So where this beta 1 beta alpha thing we are already seen where it is coming. This is the alpha 1 beta 1 that we need to substitute here, and we need to find out the beta. Beta t is 8.6368. That is the beta t. Next, pgt is 800 megawatt. That is also given in the problem. That is also 800 megawatt. Yeah. So if 4 units operate to meet the total plant load of 800 megawatt, that is also given in the problem. That is 800 megawatt. What is the incremental fuel cost of the plant? That is lambda. Here it is wrongly written as alpha. Lambda is equal to alpha t into pgt plus beta t. So here also wrongly written as beta bt. It is beta t. So alpha t what already we found out, that is alpha t is equal to 0.002176 2176. This is alpha T into PGT. PGT is 800 megawatt plus beta T. Beta T already we have calculated as 8.368. So that we need to substitute and find out the lambda. That is, if you find out the lambda, that will come like $10.1088 per megawatt hour. That is the lambda. Next, economic dispatch values for each unit we need to calculate. So what is the economic dispatch for each unit, in the sense by using the lambda iteration method. But previous classes we have solved using the lambda iteration method. There we derived this formula in our previous classes. That is PGI is equal to lambda minus BA divided by 2AI. But here in this problem, incremental fuel cost is given. That is differentiated value is given. So that is alpha is equal to 2A. So this formula, the above formula, can be rewritten as PGI is equal to lambda minus beta I divided by alpha I. So alpha I is nothing but 2AI, because differentiated value they have given in the problem. So that alpha I we have taken. So that is alpha I we have taken. So PGI is equal to lambda minus beta I divided by alpha I. So here we similarly we need to calculate the economic load dispatch value for first generating unit. That is PG1 is equal to lambda minus beta 1 divided by alpha 1. So lambda what already we found out as 10.1088 minus beta 1 what minus 9 divided by alpha 1. It is given in the problem as 0.012. Just we need to simplify. We are getting the answer as PG1 is equal to 92.4 megawatt. Similarly, PG2. PG2 is equal to lambda minus beta 2 divided by alpha 2. So lambda what already we solved, that is 10.1088 minus beta 2 is 6 divided by 0.0096. So PG2 has 428 megawatts. Similarly, PG3. PG3 is equal to lambda minus beta 3 divided by alpha 3. So lambda is, so already solved, we found out that is 10.1088 minus beta 3 from the problem, my 8 divided by alpha 3, 0.008. So PG3 we are getting the answer as 263.6 megawatt. Next, similarly PG4. PG4 is equal to lambda minus beta 4 divided by alpha 4. So lambda what 10.1088 minus beta 4 minus 10 divided by alpha 4, 0.0068. We are getting the answer as PG4 as 16 megawatt. Now, generating units PG1, PG2, PG3, and PG4 satisfies the plant load 800 megawatt. If you add all these things, we are getting the 800 megawatt. Now, minimum and maximum operating limits also given in the problem. So that is what minimum and maximum operating limits. So given in the problem as a maximum operating limit as 200 megawatt, 400 megawatt, 270 megawatt, and 300 megawatt, and the minimum operating limits given in the problem as 50 megawatt, 100 megawatt, 80 megawatt, and 110 megawatt respectively. So these are the minimum and maximum operating limits given in the problem. Yeah. So now what I did is I have written all the generating units, whatever we found out, that I have written, and also minimum and maximum operating limits also I have written. That is PG1 is equal to 92.4 megawatt. That is 50 megawatt less than or equal to PG1 less than or equal to 200 megawatt. Similarly, PG2 is equal to 428 megawatt. That is 100 megawatt less than or equal to PG2 less than or equal to 400 megawatt. Similarly, whatever we calculated PG3 as 263.6 megawatt, comma 80 megawatt less than or equal to PG3 less than or equal to 270 megawatt. Similarly, PG4, whatever we calculated, that is 16 megawatt, that is 110 megawatt less than or equal to PG4 less than or equal to 300 megawatt. These are the power generating units, whatever we calculated, and also minimum and maximum operating limits also, whatever in the problem that we I have written. Now, even though the power generating units PG1, PG2, and PG3 and PG4 satisfies the total load, that is 800 megawatt, but here you see PG1 satisfies within the limits, that is minimum and maximum operating limits, that is within 50 and 200 megawatt. But PG2 violates its maximum operating limits or upper operating limits. And also here you see PG3, PG3 also within the limits, that is 80 megawatt and 270 megawatt, that is within the limits. Next, if you take PG4, it is violating the minimum operating limits because it is 16 megawatt, but it is violating the minimum operating limit. So we need to write the conclusion like even though the power generating units PG1, PG2, PG3, PG4 satisfies the total load, unit 2, that is power generating unit 2, violates the maximum operating limits, and unit 4 violating its minimum operating limits. Now what we need to do, already we solved similar kind of problem. First, we are assuming the unit 2 to its maximum operating limits, that is PG2 as 400 megawatt. So whatever the generating units violating its operating limits, that is lambda iteration method. Lambda iteration algorithm already we have seen. So that video also I will give in the description. You can watch and come again to this problem. So here, what is this? We are first we are assuming PG2 as 400 megawatt. If because we are fixing the PG2 to its maximum operating limits, because it is violating the maximum operating limits, we are fixing. Now we are fixed, but we don't know. If PG2 is 400 megawatt, then all the generating units, that is PG1 plus PG3 plus PG4, will be 400 megawatts, because total demand, that is total load, that is given in the problem as 800 megawatt. So if it PG2 is 400 megawatt, next all other generating units will be the 400 megawatt. So now just we fix it, but we need to confirm whether whatever we fix that value is correct or not. So what we need to do is we check for the optimality condition. 3 optimality condition already we derived in our previous classes. So which optimality condition it falls is DFI divided by DPGI is less than or equal to lambda for PGA is equal to PGA maximum. So what we need to do is, because it is violating the maximum operating limits, we fix the value to its maximum operating limit. So this second condition, that condition we need to satisfy, that is a DF2 divided by DPG2. By taking PG2 as a 400 megawatt, so we need to find out what is a DF2 divided by DPG2. So just to substitute 400 megawatt here, because already this DF2 divided by DPG2 already given in the problem. The same thing we are returning here, because once again I'm showing that already in the problem itself DF2 divided by DPG2 is given. DF2 divided by DPG2, same thing only we are writing over here. So we are substituting here and taking the PG2 as 400 megawatt, simplifying, we are getting the answer as 9.84. 9.84, just we are substituting 400 here, we are getting the 9.8. So 9.84 is less than 10.1088. That is lambda. So this is the condition. This is the condition. DFI divided by DPGI is less than or equal to lambda. So this answer we are getting some 9.84, that is less than. So this condition satisfied. Now we are confirming that PG2 is 400 megawatt. So just like that, you should not fix it. You need to satisfy the optimality condition. Now with the remaining all the 3 units, we need to calculate the lambda. Because 1 unit we fixed it. First, again, we need to calculate the lambda. So lambda nu. So how to calculate lambda? So alpha t is equal to 1 divided by alpha 1 plus 1 divided by alpha 3 plus 1 divided by alpha 4, the whole inverse. Here we skipped lambda 2 alone. Sorry, alpha 2 alone. Why? Because already we fixed the generating 2 as a 400 megawatt. So we are eliminating this alpha 2 here. So you should be very, very careful while calculating again lambda. Okay, so if you add again this, again the answer will come wrong. The whole problem goes wrong. So you need to be very, very careful at this point. So now we are substituting alpha 1 here. Alpha 1 is 0.12, 0.012. Alpha 3 is 0.008. Next, alpha 4 is 0.008. 0.0068, the whole inverse. So we are getting the answer as alpha t as 0.002813. Similarly, here beta t what? Beta t is equal to alpha t into beta 1 divided by alpha 1 plus beta 3 divided by alpha 3, beta 4 divided by alpha 4. Here also, we are neglecting the second term, that is beta 2 divided by alpha 2, we are neglecting because already we fixed it. So now just we are substituting from our problem data. So alpha t what already we calculated, that is 0.002813, beta 1 9 divided by alpha 1 0.012 plus beta 3 is 8 divided by alpha 3 is 0.008. Next beta 4 is 10. Next alpha 4 is 0.0068. Simplifying with your scientific calculator, we are getting the answer as 9.0620. Next, what is the incremental fuel cost alpha? Alpha is equal to alpha t into PGT plus beta t. Already we have seen this equation. So here, just like that, we need to substitute what is alpha t and beta t. Alpha t already we calculated 0.002813 just and beta t also we already calculated 9.0620. Just we are calculating. Now we are taking PGT as a 400 megawatt. How PGT as 400 megawatt? In the sense PG2 we are considered as 400 megawatt. So total load is 800 megawatt. So PGT is nothing but this minus this. That is 800 minus 400 is 400 megawatt. Now we are substituting PGT as for PGT as 400 megawatt here. Next calculating lambda. So lambda after simplifying, we are getting the lambda value as $10.1875 per megawatt hour. So you just tell in the comment whether you are getting the same answer or not. Because if I am wrong or you are wrong. So I think what I solved is correct. But once you check whether the same answer you are also getting or not. Next, lambda is equal to $10.1875 per megawatt hour that we calculate. Now with this lambda, what we need to do is we need to calculate PG1, PG3 and PG4 by using the lambda iteration method. So lambda iteration method already we know. The formula also we modified before. So by using this lambda, that is PG1 is equal to lambda minus beta 1 divided by alpha 1. But in the actual lambda iteration method, the formula is lambda minus bi divided by 2ai. But here incremental cost is given, that is differentiated value is given. So just like that, we are taking as alpha 1. That is PG1 is equal to lambda minus beta 1 divided by alpha 1. Substituting the values for beta 1 and alpha 1 here and also lambda. Lambda also we calculate as 10.1875. Simply we are substituting here and we are getting the PG1 as 98.9655 megawatt. Similarly, PG3 also lambda minus beta 3 divided by alpha 3. Substituting the values for beta 3 and alpha 3, we are getting the answer as 273.4483 megawatt. Similarly, PG4 is equal to lambda minus beta 4 divided by alpha 4. Similarly, substituting all these values, we are getting the answer as 27.5862 megawatt. Now we are writing all the answers. That is PG1 is equal to 98.9655 megawatt. Like a minimum and maximum operating limits 50 megawatt less than or equal to PG1 less than or equal to 200 megawatt. PG2 already we fixed it. That is 400 megawatt, comma 100 megawatt less than or equal to PG2 less than or equal to 400 megawatt. Similarly, PG3 is equal to already we calculate 273.4483 megawatt, comma 80 megawatt less than or equal to PG3 less than or equal to 270 megawatt. Next, PG4 is equal to 27.5862 megawatt, comma 110 megawatt less than or equal to PG4 less than or equal to 300 megawatt. So it is absorbed that unit 3 violates. Unit 3 again, unit 3 and unit 4 violates its maximum and minimum operating limits, because unit 3 you see 273.4483 megawatt, it is violating its maximum operating limits or upper operating limits, and PG4 it is 27.5862 megawatt, it is violating its lower operating limits or minimum operating limits. So Now we need to write the conclusion. So consequently, it is concluded that other generating units beside the unit 2 need be operating at their limits if the output of the unit is specified as 400 megawatt. So whatever the considered, so out unit 2 we consider now 400 megawatts, and by considering unit 2 as 400 megawatt and solving for all the generating units, so that gives again violating the operating limit. So unit 2 need not to be its 400 megawatt. Now we are going for case 2. Case 2 means unit 4 violates its minimum operating limits, no, from the first. If you go to the first, so unit 4 here, what we did is up to here, you understood, no? So here, unit 2, we were taken as 400 megawatt, and further we solved the problem. But even though we have taken unit 2 as 400 megawatt, the again, it is not satisfying the minimum and maximum operating limits. Now, case 2, what we are doing is unit 4 is there. Now, unit 4 violates its minimum operating limits. That is minimum operating limits here. That is 110 megawatt. So we fixed the unit 4. We fixed the unit 4 as 110 megawatt. Again, further we are proceeding the economic load dispatch problem. That is the case number 2. So we are fixing the unit 4, that is unit 4 as to be its minimum operating limits, that is PG4 is PG4 as 110 megawatt. Now further we are proceeding the problem. So if we are considering the unit 4 as 110 megawatt, then the total output of all other generating units, that is 1, 2 and 3 should be 690 megawatt, because total demand that is given in the problem is 800 megawatt. Now, just we fixed it. Again, we need to check whatever the fixed value is correct or not. So which condition it falls, it is violating its max minimum operating limit. So it is falling under this optimality condition. That is DFI divided by DPGI is greater than or equal to lambda for PGI is equal to PGI minimum. So DF4 divided by DPG4 by taking PG4 as 110 megawatt. This DF4 divided by DPG4 already given in the problem data that we are taking over here, and we are substituting PG4 as 110 megawatt, and we are finding out the DF4 divided by DPG4 as 10.748. So here this condition we are checking, that is 10.748 is greater than that lambda whatever we calculated before is 10.1088. So this condition satisfied. Now we are considering PG4 as 110 megawatt. By considering PG4 as 110 megawatt, again we need to frame the incremental fuel cost. So by using the alpha T, by using the new incremental fuel cost lambda nu, we need to find out. So how to calculate lambda nu? Because we need to consider all this generating unit 1, 2 and 3, and we need to neglect the unit number 4, because already we fixed the unit number 4 as 110 megawatt. So now again we are calculating alpha T. Alpha T is equal to 1 divided by alpha 1 plus 1 divided by alpha 2 plus 1 divided by alpha 3, the whole inverse. Just substituting the values for alpha 1, alpha 2 and alpha 3, simplifying, we are getting the answer as alpha T as 0.0032. That is nothing but 3.2 into 10 to the power of minus 3. Similarly, beta T you need to calculate. Beta T is equal to alpha T into beta 1 divided by alpha 1 plus beta 2 divided by alpha 2 plus beta 3 divided by alpha 4. Here alpha 3. Here also fourth generating unit we are neglecting. So further we are substituting all the values for beta 1, beta 2, beta 3 and alpha 1, alpha 2 and alpha 3 and alpha T. Here we are getting the beta T as 7.6. So what is the general format for calculating the incremental fuel cost? Lambda is equal to alpha T into PGT plus beta T. So PGT, you know, 690, because this fourth generating unit we neglected. So PGT is equal to 690 megawatt. So here alpha T already we calculated that value as 0.0032. That we are substituting here. 0.0032. Next into PG3690. Beta T also we calculated as 7.6. Further simplification, we are getting the alpha as $9.808 per megawatt hour. But now by using this alpha, again we are going to calculate the PG1, PG2 and PG3 by using the lambda iteration method. Here already I said how the formula modifies. That is lambda minus beta 1 divided by alpha 1. So just to substitute beta 1 and alpha 1, we are getting the answer as 67.34 megawatt. Next, similarly, Pg2 is equal to lambda minus beta 2 divided by alpha 2. Just we are substituting lambda as already we calculated, that is 9.808 minus this value, that is beta 2 and alpha 2 values. After substituting, we are getting the answer as 396.667 megawatt. Similarly, Pg3. Pg3 is equal to lambda minus beta 3 divided by alpha 3. Just we are substituting the values for beta 3 and alpha 3. So we are getting the answer as 226 megawatt. Now, and also already we fixed the PG4 as 110 megawatt. Now we need to check whether all the generating units are within the minimum and maximum operating limits. This is already given in the problem. This is not be considered, already given in the problem. That is for power generating unit 1. The minimum and maximum operating limit is 50 megawatt less than or equal to PG1 less than or equal to 200 megawatt. Yes, it is falling under the minimum and maximum operating limits, because whatever the answer we got for PG1 as 67.34 megawatt. So it is within the minimum and maximum operating limits. So similarly here PG2. PG2 also here whatever we calculated as 396.667 megawatt. Here also, this is also within the minimum and maximum operating limits. That is within the 100 and 400 megawatt. Here, next PG3, whatever we calculated as 226 megawatt. And also it is falling under the minimum and maximum operating limits. That is 80 megawatt less than or equal to 270 megawatt. So it is within the minimum and maximum operating limits. So similarly, PG4 also should be within the minimum, because we fixed it, so it is also defaultly it is in the minimum and maximum operating limits. So now we need to write the conclusion like all the generating units PG1, PG2, PG3 and PG4 satisfies the minimum and maximum operating limits, and also it satisfies the total demand or total load of 800 megawatt. So now therefore the economic dispatch requires the output of unit 4 that is set to its lower operating limits 110 megawatt. So whatever the we consider, that is PG4 as 110 megawatt, no? So that is only giving the economic dispatch results. And also it is satisfying the minimum and maximum operating limits. But the previous case, what we considered, that is second generating units we fixed, no? So while solving the second generating unit as a yeah, we fixed it and we solved. Further we solved, no? Yeah, PG second generating unit as 400 megawatt, and further we solved. That answer is even though it's satisfying the demand, but it is not satisfying the minimum and maximum operating limits. So this is wrong. This is wrong means, so whatever the generating units and we consider as 400 megawatt, it is not giving the economic load dispatch results, and also it is not satisfying the minimum and maximum operating limits. So this should not be the economic load dispatch values. Whatever the we consider, that is case number 2, that is PG4 as 110 megawatt. So that is giving the economic load dispatch values, and also it is satisfying the minimum and maximum operating limits. So like that, you need to conclude this problem. So this problem, they may ask at a 10-mark question, like a big question, they may ask a 10-mark question, but very simple. The thing is that the formula we need to substitute, and we need to do it for two cases. Here we got two cases, no, because two generating units not satisfying the limits. So that two cases also you need to calculate, and which case is giving the economic dispatch value, and also which case within the maximum and minimum operating limits, that is the economic dispatch value for this particular problem.